right, welcome back, everybody. Thank you so much for tuning in to this is the world's very first Hydroplate Conference, and the speakers just keep getting better and better and better. And we are blessed to have with us Dr. Robert Brown. He was in the Air Force for 21 years as a pilot and a professor, and now he's a professor of astronautics at, get this, the U.S. Air Force Academy. So somebody from the U.S. Air Force Academy is on our side. That's quite a feather in our hat. And he's had has papers that are published in Technical Journeys, and he's also Walt Brown's son. And so I'm so glad that he is here, and I don't want to take up any more of his time. So everybody, this is Dr. Robert Brown.
Hi, thank you for having me here. It's an honor to be speaking with you today. I want to share my screen, and we'll be talking about trans-Neptunian objects today. I'll explain what those are, and I want to talk about the evidence with TNOs, they're called TNOs for short, that supports the hydroplate theory. This is a picture of Ultimate Thule, a trans-Neptunian object, and these are objects that remain outside an average distance from the sun further away than Neptune. Neptune is 30 astronomical units from the sun, and to give you perspective, an astronomical unit is the distance the Earth is from the sun. So Neptune's 30 times further away from the sun, and this thing is 43 astronomical units from the sun. That puts it 1 billion miles beyond Pluto's orbit. So it's a long way out there. And this picture was taken in 2019 by New Horizons. New Horizons swept within just over 2,000 miles of Ultimate Thule and took this picture. And it's kind of puzzling to scientists. It's called a contact binary. These two objects came together without destroying each other, which is amazing because at the velocities they're moving, if they hit each other, they would just pulverize each other. But they just came down and touched each other. And a lot of scientists have trouble understanding why this happened or how this happened. They also discovered there's water ice on the surface of this. And I believe that the water ice can explain how they came in contact. It helped explain how they came in contact. And if you saw Kevin's talk a little while ago and Doug's talk, you may have an idea of what I'm talking about. We'll get to that a little bit later. But first of all, I'd like to give you an outline of what I want to talk about. I'm going to briefly share some of my background, although Brian's already talked a little bit about it. Then I want to talk about the hydroplate theory's explanation for asteroids, comets, and TNOs. You've probably heard some of this already if you've attended the previous talks, but the hydroplate theory proposes that TNOs came from the same source as asteroids and comets, and I'll cover all of those briefly. And then I want to talk about other explanations that evolutionists would say for TNOs. And then we'll look at the evidence, and you can decide which theory best supports the evidence of TNOs. And we'll start by looking at Pluto. That's the most famous, well-known trans-Neptunian object, and Pluto's moons. And then I'm going to talk about some research I've done on TNO orbits that are much, much farther from the sun. And the evidence there indicates that I think it points directly towards the hydroplate theory. So real quickly, my background. As Brian said, I'm a professor now, and typically when people talk to a professor, they want to know, well, what's your academic credentials? And I have a Ph.D. in astronautical engineering, and I've attended 4 different graduate schools. But probably for this group, the most important thing about my educational background started when I was a little child, and my father's Dr. Walt Brown, so I had what in hindsight now is a tremendous benefit. I grew up in a home where constantly there'd be discussions about, look at the moon, Rob. Where do you think that came from? How long do you think it's been there? And discussions like that related to the scientific evidence that supports creation and a worldwide global flood. I have published 3 papers on trans-Neptunian object orbits that I will be referencing today and talking about. As Brian said, I spent 21 years in the Air Force, and I've also spent 21 years as a professor of astronautical engineering at the Air Force Academy. This is probably the appropriate place to mention, this is a disclaimer the Air Force Academy made me put in my slides, that the views expressed here are my views. They don't represent the views of the Air Force or the Air Force Academy, and I hope that'd be obvious, but now it's clear. All right, let's get into it. What's the explanation for comets, asteroids, and TNOs? Well, hydroplate theory says that on the same day all the fountains of the Great Deep burst open. Certainly most of this came down as waters that covered the Earth and caused the global flood, but I believe some of this was launched into space and became comets, asteroids, and trans-Neptunian objects. And believe about 3% of the Earth's mass left to become these objects. And this would include muddy water, rocks, boulders, even some organic material, and some of the atmosphere. And I think some of this hit the moon, and Doug had a whole talk on this, and there's a lot of evidence for that. And in fact, he talked about the Apollo rocks that were analyzed, and they decided they came from Earth. That was published in the journal Science, which, in my opinion, is probably the one or two most highly respected technical journals there is. And what's interesting is they said it formed in a water-rich environment, but most likely came from the Earth, but not the surface of the Earth. They said 12 miles below the surface is where it had to come from, given the heat that it had to form at. 12 miles below the surface in a water-rich environment. That sounds like the hydroplate theory to me. But we're going to go right past the moon and start talking about things that went out further into space. I want to talk about what would have caused, what would this have done as it's moving away from the Earth. Well, I think the debris would have been moving in large swarms around the largest boulders as they moved away from the Earth. And as Doug explained very well, as they moved away, their sphere of influence would get bigger as they moved further away from the Earth and eventually further away from the sun, and their gravitational attraction of all those things around them would allow them to capture more of those things. And the smaller debris, especially the water which would have frozen, would act as aerobraking and cause some of those smaller rocks to slow down and lose energy, allowing them to slowly coalesce into one large pile of rocks. But these large swarms, I think, would have been propelled away from the sun by three forces, and I want to talk about those forces now. First of all, solar wind pushes things away from the sun. This is a picture on the bottom left is a picture of a satellite, and some satellites actually use this to move away from the sun. The solar sails on satellites on the order of a few meters in diameter, but these swarms initially that I'm talking about from the hydroplate theory would have been thousands of miles in diameter. So there's a large area that would catch those photons, and it's not a large force, but it's a constant force that's constantly accelerating you away from the sun. There's also something called a radiometer effect. I'll explain that here, but the bottom picture in the middle of the slide is a radiometer. It's a bulb with a little bit of gas in that bulb, and there's veins there. One side is black of the veins, and one side is white. The black side gets a little bit warmer when it's in the sun than the white side, and then the gas molecules will bounce off that warm side with more momentum and propel the veins away from the black side. That would also happen with these rocks. The one side would be warmer, and the molecules would bounce off that with more momentum and push them away. The third explanation I want to explain is called the Yarkovsky effect. The Yarkovsky effect is similar to the radiometer effect with a slight difference, and this has been documented in technical literature as something that moves satellites in space. The picture on the far right shows this. The sun is in the bottom of the picture, and the large black object at the top would be a trans-Neptunian object, obviously not to scale. Now, most things in the solar system orbit as you look from the northern hemisphere in the counterclockwise direction that's shown here. And they also rotate on their axis in a counterclockwise direction. And because of that, the warmest spot of that TNO is not the spot that's closest to the sun. It's actually, which would correspond to like 12 noon. It's actually a little bit in the picture to the right of that, which would correspond to maybe 1 or 2 in the afternoon. And just like on Earth, the warmest part of the day is 1 or 2 in the afternoon, not at 12 noon. And because of, and likewise, the coldest spot is not at the spot that's furthest away from the sun, corresponding to midnight, but at 1 or 2 in the morning. Because of that, the molecules, especially the water molecules, would bounce off the hot side, and the thrust would not be radially away from the sun, but it would have a little component in the direction that the TNO is moving. And that's what that red vector is on the TNO. It's showing the thrust. The component that would be in the direction it's moving is going to add energy to that orbit. And slowly over time, that orbit's going to spiral out in roughly a circular orbit due to this thrust. And the papers that I discussed, I speculated that this may have been the force that moved them away from the sun, the Yarkovsky effect. And just to put it in perspective, you think about, well, the difference in the hot side and cold side is not that significant, but you're thinking of someone who lives on Earth. Just to give you an idea, on the moon, the temperature on the dark side of the moon is 200 is negative 270 degrees, negative 270 degrees Fahrenheit, and in the sun it's 240 degrees Fahrenheit. So there can be huge differences in space on the hot side and cold side. And I think these forces propel things away from the sun in roughly circular orbits, primarily near the plane of the ecliptic, because the Earth was already moving in that plane when it launched all the objects. Now I'm going to cover this kind of briefly because Kevin did a really good job talking about some of the hydroplate theory predictions about asteroids and comets. And I want to cover the asteroids and comets together because hydroplate theory says asteroids and comets and TNOs all came from the same source. Well, in 2001, my father predicted in writing, based on the hydroplate theory, that asteroids and comets would be found to be large rock piles. And the larger rocks would need to be near the center, and they would often have ice acting as weak glue. This is what was discovered 4 years later with Ceres. It was the largest asteroid was found to be have rocks on it with a large rocky inner core, but smaller rocks on the outside. And Kevin had fabulous videos of the DART mission showing this to be the case. Here's an asteroid called Galt. It's got water vapor coming off of it. Here's another asteroid that called P213P5. Scientists studying this looked at it for 5 months, and they said it looked like a rotating lawn sprinkler with water coming, vaporizing off of it. My father also predicted that most rocks would be rounded on these. And he said that a large asteroid, if it had an impact, would release vast amounts of water vapor. And we've seen that to be the case too. Kevin talked about it. Here's Comet 67P that was studied by the European Space Agency. I'll zoom in a little bit more. There's a close-up of it. And the technical papers describe this as it looked like it has goosebumps all over it, or large dinosaur eggs. They weren't saying they were dinosaur eggs. It just looked like it. They said they're boulders about 10 meters in diameter, but they were rounded and smooth, and they couldn't explain why. Well, the hydroplate theory explained why, because it was predicted years before. It was just erosion during the fountains, when the fountains of the Great Deep launched them. They became smooth, just like rocks in a mountain stream would become smooth over time. But it happened very quickly when the fountains of the Great Deep erupted. Now, before we get into the evidence, let's talk about what are some other explanations for TNOs that evolutionists would say, how did they get there? Well, one common theory is they just formed in their current orbits from planetesimals. Now, planetesimals are what evolutionists think form planets. I should interject, though, that they have no explanation for how they formed into planets, but think of it as little pieces of planets. A problem by their own admission, though, is planetesimals that far away from the sun would be too spread out to ever form into a planet. And again, I would add, they haven't explained how planetesimals formed into a planet in the inner solar system either, so that's another problem. Another theory is that the TNOs formed closer to the sun, and then they were dispersed when Neptune moved away from the sun. There's some problems with this. First of all, there's no explanation for why Neptune would ever move away from the sun. It's a huge planet, and there'd be a lot of force to actually cause it to move away. Another problem is perihelion, which is the closest distance something comes to the sun, would never be greater than 30 astronomical units. If Neptune flung them out to the orbits they're in, they would fly out to the orbits that they're in now, but then they'd come right back down to where the Neptune perturbed them, and that would never be more than 30 astronomical units. And as you'll see, there are many, many TNOs, that are well beyond 30 astronomical units now and never get close to Neptune today. And finally, another problem is there are many binary trans-Neptunian objects, and some of them are really, really far apart. They're called ultra-wide binaries. And everyone who studied them said that a close pass to a giant planet would pull those fragile orbits apart from each other, and we wouldn't have those orbits today. So they probably never came close. They certainly never came close to Neptune. And so that's another problem with this theory. A third theory proposed by evolutionists is the TNOs just formed in their present locations from collisions of small planetesimals. Well, there are a number of problems with this. First of all, collisions wouldn't happen that frequently. They would be too high of a velocity. They would destroy the TNOs, and they would also separate the binaries. So there are problems with all of these, and these are problems that are pointed out by the evolutionists who proposed them. Now let's look at the evidence, and you decide, does the evidence support one of these theories or the hydroplate theory explanation that I just gave? We'll begin with looking at Pluto. It's the most famous TNO, probably because you and I grew up thinking it's a planet. And because of that, I think most people think Pluto is huge. It's not that big. It's only about 0.22% of the Earth's mass. And it's not that dense either. It has 5 moons. That's puzzling. Scientists can't really explain how any asteroid or TNO captures a moon, because what happens when something comes in space near each other, some object is flying in really fast on a hyperbolic orbit, it just shoots around that object and then shoots out on the other side of the sphere of influence with the same velocity it came in with. There are only 2 things that can really help it be captured, and one is if it's moving away from the sun, then its sphere of influence will get bigger. And maybe in the time that that object flew into the sphere of influence, before it flew out, the sphere of influence would be big enough to capture it. Or if there's aerobraking, which the hydroplate theory would also say was there, that would slow the velocity down and allow it to capture things. But Pluto has 5 moons. It has an atmosphere, and it's losing about 500 tons of its atmosphere every hour from just solar wind blowing it away. Which begs the question, one, where did the atmosphere come from, and how long has it been there? Scientists were surprised to see mountains of water ice and lakes of nitrogen liquid ice and frozen carbon monoxide lakes on Pluto. They're towering mountains and in absence of craters, which made scientists surprised. They said, this is really a very, very young surface. And I don't think they realize how young it is. Charon, Pluto's largest moon, has crystalline water ice on the surface. And the fact that it's crystals poses a big problem for evolutionists. Those crystals could only form at temperatures above negative 260 degrees Fahrenheit, but the temperatures there are about negative 370 degrees Fahrenheit. So at one time, it had to be much, much warmer. Also, after just 40,000 years, ultraviolet light and cosmic rays would randomize these ice molecules, and they would no longer be in crystal forms. So that means the upper limit of these crystals, and possibly Charon's, the entire moon, is 40,000 years. And so that is a big hurdle for evolutionists to get over. Now I want to jump into the research I've done, and published it in 3 technical journals. I want to summarize the research first, and then I'll get into the details. And the summary of my research is TNOs have not been in their present orbits very long. And when I say very long, I think it's been about 5,000 years, but my research shows it's been less than a few million years. And I know that's a very long time for a young Earth creationist, but for an evolutionist, that's shockingly young. I also conclude that TNOs migrated from inside Neptune's orbit. And I'll show you the data in the next slides that show that. Well, first of all, let me explain the problem as you go well beyond Pluto's orbit. Some TNOs are way, way out there, and they're in similar orbits. For example, here's one of the more famous ones, Sedna. It has a value of A, that's the semi-major axis, which is the average distance it is from the sun, of 524 astronomical units. And remember, Neptune is 30 astronomical units from the sun. Its period to go all the way around the sun is 11,400 years. It has a little q, which is the radius of perihelion. That's the closest distance it gets to the sun, is 76 astronomical units. So you see, this never gets close to Neptune. And it's about 618 miles in length. It's a pretty big object out there, and it's way, way out there. Well, there are a number of these that are about 6 to 12, depending on how you classify them, that are out there this far. And their argument of perihelion, which I'll explain in a bit, is this little omega. It's close to 0 degrees for most of these orbits with a large semi-major axis. Let me explain what argument of perihelion is. In this picture, the sun's the dot at the center. The green plane is the plane that the Earth makes around the sun. It's called the plane of the ecliptic. The blue plane is the plane that the TNO makes. It's the orbital plane. And as it gets, in the top right corner of this picture is perihelion, the TNO's closest path the closest point it gets to the sun. As the orbital plane intersects the plane of the ecliptic heading into the northern hemisphere, from that point, you measure the angle up to where perihelion is, and that's where argument of perihelion is. So in this picture, the argument of perihelion is about 90 degrees. But I said most of these have an argument of perihelion close to 0, which would put it down near the plane of the ecliptic. Other studies have shown that they have a similar inclination. And other studies have shown it's not due to observational bias. Now, there was a famous paper, a well-known paper that came out, and they noted these clustering, and they said, how could they have been clustered for billions of years like this? They said there has to be another planet out there. And they said, there's a planet 9. It's a huge planet. It's got to be 250 astronomical units from the sun. And they have a very specific location where it should be. And they said that should be found within 2 years. Well, they made that prediction about 8 years ago, and they still haven't found it. And I have a different explanation. I don't think they've been there that long, but we'll come back to that in a bit. Now, I looked at all the TNOs that remain outside Neptune's orbit. And the time I did the study, there was a little over 1,600 of them. This is a plot in the bottom of the figure showing on the x-axis is the semi-major axis, the average distance these are from the sun. And the y-axis is what is their argument of perihelion in degrees, going from negative 180 to positive 180. The 9 largest dots on here are what I call the long period TNOs. Some people call them the extreme TNOs. These are the ones that have a semi-major axis greater than 200 astronomical units. And you see that those large dots are kind of clustered near the middle of this picture. I said around 0. It's really around negative 18.6 degrees. But the probability of that happening by chance is only 0.07%. So it's probably not something random. And then the smaller dots are all the other TNOs. Now, I was the first one to also look at the distribution of all the TNOs. I'm sorry, this is remembering what the little omega is. I was the first person to look at the distribution of all the TNOs, and here's a histogram showing what those look like. Now, in this plot figure, the x-axis is what's the argument of perihelion in degrees, and these are each 10-degree buckets going from negative 180 on the left to positive 180 on the right. And the y-axis is how many TNOs fall in each of those buckets. The white bars show all of the TNOs that remain outside of Neptune's orbit. And again, at the time I did this, I believe there were 1,601 of these. And you notice they have a peak right around 0 and around 180 or negative 180 degrees, which would be the same number. They're not uniformly distributed. And the black bars here are those 9 long period TNOs that I had showed as big circles in the previous plot, only I had to multiply them by 10, otherwise they wouldn't have shown up on the y-axis. And I mathematically showed that these white bars match the distribution of 2 normal overlapping normal distributions centered on 0 and 180 degrees. And I also showed that statistically, those black bars could have come from the same distribution of those 2 normal distributions overlapping each other. So the big takeaway here is the argument of perihelion is not uniformly distributed for any of the TNO, for all the TNOs, let alone the ones that are way out there. And it tends to be centered closer to a lot more near 0 and 180 degrees. And again, here's what this picture is of little omega. So if little omega is 0, that means perihelion is near the plane of the ecliptic as the TNO is moving north. And if little omega is 180, that means perihelion is near the plane of the ecliptic as the TNO is moving south. All right, let's move on now. The other thing I was the first person to notice is it's not just that orbital element that's clustered. There's another one called the right ascension of the descending node. And I'll explain what that is in a bit. But this is another angle to talk about the swivel of the orbit. In this figure, the x-axis is still the semi-major axis, going from 0 out to 600 astronomical units. And the thin line is at 200 astronomical units. In this case, the y-axis is what's the right ascension of the descending node. And again, the larger dots here show the 9 long period TNOs that have an average distance of more than 200 astronomical units from the sun. And you notice they're clustered near the top of this figure around 122.7 degrees. The probability that that would happen by chance, that they'd be clustered that closely, is 0.09%. And again, the smaller dots are all the other TNOs. Now let me explain what this argument or right ascension ascending node is. On the same figure, I added a vector showing the first point of Aries. This is a reference point that astronomers use. It lies in the plane of the ecliptic, and it points to a star that's so far out there, it essentially doesn't move even as the Earth goes around the sun. And the angle from that vector to the point where the Trans-Neptunian object cuts through the orbital plane cuts through the plane of the ecliptic heading north, that angle is called the right ascension ascending node. So basically it measures the swivel of the orbit. Again, I looked at the distribution of all of them and found they're not uniformly distributed either. This is similar to the figure earlier. It's a histogram. On the x-axis now is different buckets of 10-degree increments of the right ascension ascending node. And then the y-axis is just what's the frequency of TNOs in each of those buckets. And you'll see, and again, the white bars are all the TNOs, and the black ones are the 9 long period TNOs, but I had to multiply them by 10 so they would show up on the y-axis. You notice the majority of these fall between 20 and 180 degrees, but there's a real big peak right around 120 to 140. And that's perplexing because there aren't too many on the other opposite side. So, and let me deviate a little bit now. I did another paper saying, how long could these have been here? Well, some people propose Planet 9 to explain just the clustering of 6 to 12 of these long period TNOs. But I showed, hey, there's not a problem with the clustering just of 6 of these or 12 of them. I looked at 1,600 and said, they're not uniformly distributed. What would keep them in the same place? And people who proposed Planet 9 said, a giant planet has to be there to gravitationally hold those 6 to 12 TNOs in those same orbits for billions of years. And I said, well, it's not just 6 to 12, it's 1,600 that you have to keep non-uniformly distributed. Then I did a simulation with a colleague, a coworker of mine, and we simulated all the TNOs backwards and forwards in time, accounting for the gravitational forces from the sun and all of the giant planets. And we showed that just after 3 to 5 million years, these orbital elements should be uniformly distributed. And they're not uniformly distributed today. Therefore, we concluded they haven't been there for more than a few million years. We also did another simulation. We said, what if Planet 9 was there? Could this explain this non-uniform distribution? And we put Planet 9 at the spot where the people who proposed it think it is, and it doesn't solve the problem. They're still uniformly distributed within 3 to 5 million years. Therefore, I postulate that Planet 9 doesn't exist. There's no reason for it to exist. And sure enough, the people who proposed it said it would be found within 2 years, and that was about 8 years ago, and they still haven't found it. Now, let's summarize all this research. I showed that neither the argument of perihelion, that's little omega, nor the right ascension ascending node, which is capital omega, is uniformly distributed today. And they'd be evenly distributed after a few million years. I showed that the argument of perihelion is near 0 degrees or 180 for many of these TNOs. And that indicates something near the plane of the ecliptic may have perturbed them and flung them above or below the plane of the ecliptic. Also, I showed that the right ascension ascending node, that's the capital omega, is clustered around 120 to 140 degrees for many of these, which is very similar to Neptune's value of 132. And again, this is to remind you what those are. So here's what I proposed. I said that TNOs recently went past Neptune's orbit. Remember, they haven't been in their orbits that long. And if they went past Neptune, it could explain some of the orbital elements we see. I say many of them were pulled close to Neptune's orbital plane, resulting in a right ascension ascending node about 132 degrees. And again, that's what the right ascension ascending node is. And I think some of them came much closer to Neptune and received a large gravitational boost. If it comes really close to Neptune, it's going to either speed up or slow down, and Neptune kind of fling it around. And those that sped up would have increased the value of A, which is the semi-major axis, the size of the orbit, and E, which is the eccentricity. I think about half of those that would have been flung by Neptune out to larger orbits would have been flung above the plane of the ecliptic. And if that would have happened, that means perihelion would have been at the point where argument perihelion is 0. and about half would have been flung below the plane of the ecliptic, resulting in an argument of perihelion, the little omega, close to 180, which could explain the distribution we see of these. Furthermore, I also proposed that many of these continued moving past Neptune's orbit because they still had a lot of the forces that I discussed earlier, the solar wind, the radiometer effect, and the Yarkovsky effect, and they might have had some momentum just continued to move past Neptune, and they're past Neptune now. I believe the long period TNOs, those that have largest semi-major axis, all came close to Neptune at about the same time and same relative position, which explains why they have similar values for inclination and argument perihelion that we see today. And I believe the ultra-wide trans-Neptunian binaries moved so fast through the solar system, they never came close to Neptune, and that's why they're still orbiting each other today. So based on this theory, what would we expect to see with the TNO parameters that we haven't looked at yet? Well, I think that the TNOs that would have moved faster through the solar system because they had larger forces of these non-gravitational forces pushing them away from the sun would have traveled farther. And so they should have the largest radius, a large radius of perihelion compared to other TNOs. I believe because they move faster, they would have been less likely to be perturbed by Neptune or another giant planet. Therefore, they should still be relatively close to being a circle, meaning eccentricity is close to zero, because I believe they spiraled out in pretty circular orbits. And if they never were perturbed, they would be still be near the plane of the ecliptic, so the inclination would be close to zero. In contrast, the TNOs that would move slower through the solar system, I don't think would have traveled a shorter distance after passing Neptune, so their radius of perihelion would be closer to 30 astronomical units. And because they move slower, they would be more likely to come in close contact with Neptune or another giant planet, resulting in eccentricity would be higher. And eccentricity is just a measure of how non-circular they are. So they would have a higher eccentricity. And they would also have a higher inclination because they would have been more likely to have been flung above or below the plane of the ecliptic. And this is exactly what we see. Here's the distribution of eccentricity. This is another histogram. The x-axis shows what's the radius of perihelion, and on the far left is 30 astronomical units, and then there's it goes all the way out to 42 astronomical units, and then I just grouped all the ones between 42 and 81 together. The row above that shows the population of TNOs in each of those buckets. So it's between 81 and 300 TNOs in each of those ranges. And then the line above, the row above that shows how many of those TNOs have an eccentricity that's less than 0.05, meaning it's almost a circle. And then I plotted those as a percentage in the plot. So the plot shows what percent in each of those ranges of perihelion distance, what percent are almost a circle. And you notice between 30 and 34 astronomical units, there are almost 400 TNOs there, and not one of them is close to a circular orbit. Whereas if you go way out beyond 42 astronomical units, almost 80% of them are almost perfect circles. And I think that's because these TNOs on the far right traveled further because they had moved through the solar system faster. They had larger forces that were pushing them away, or maybe they were launched at a higher velocity, but they moved faster through the solar system. And they spiraled out in roughly circular orbits from those forces that I talked about before. So they're still circles today. In contrast, the ones on the left were moving slower. They were more likely to come in close contact with a giant planet like Neptune, which would change their eccentricity, and they would no longer be a circle today. What about inclination? Similar plot here. X-axis shows it's a histogram showing the radius of perihelion. And now this is the population of TNOs in each bucket, and the numbers right below the plot are what number of TNOs in each of those buckets has an inclination less than 5 degrees, meaning it's still pretty close to the plane of the ecliptic today. And the plot shows what percent in each of those buckets are almost in the plane of the ecliptic, so an inclination less than 5 degrees. Between 30 astronomical units and about 40 astronomical units, it looks like maybe 20 to 30%, almost 40% with some of them are almost near the plane of the ecliptic today. But in contrast, if you go way out to be, beyond 40 astronomical units, it's 60 to 70%. are near the plane of the ecliptic. And again, I think that's because the TNOs on the far right move faster. So they got through the solar system without being perturbed and being flung above or below the plane of the ecliptic. And they're still pretty close to the plane of the ecliptic today. In contrast, the slower moving ones are on the left. They were more likely to have some of them flung above or below the plane of the ecliptic, resulting in a higher inclination. Well, now what about the ultra-wide trans-Neptunian binaries? These are the things that are orbiting really far away from each other. And I believe, like most evolutionists would say, that they never came close to a giant planet. It would have pulled them apart from each other. But I still think that they came from the fountains of the great deep. They just moved through the solar system faster, which meant that they never came close to a giant planet. Therefore, if they traveled through the solar system faster, they should have a larger radius of perihelion, because they would have traveled further away than the other TNOs. They also would be less likely, because they never came close to a giant planet, they would have never been perturbed. So they should still have a relatively circular orbit with a small eccentricity, and they should be near the plane of the ecliptic because they were spiraling in the plane of the ecliptic, and they should have a low inclination. And that's exactly what we see. Here's a table showing that. There's 7 ultra-wide trans-Neptunian binaries. There are other binaries that are just not ultra-wide, but there's 7 that are ultra-wide. And the first row here shows the little q is the radius of perihelion. Those 7 ultra-wide trans-Neptunian binaries all have a radius of perihelion greater than 41.1 astronomical units. Their average value is 42.5 astronomical units. And when you compare that with the non-binary TNOs, and there were 1,583 when I did my study, their average is 37.7. So as I expected, the ultra-wide trans-Neptunian binaries went further. They migrated further away from Neptune than the other group of TNOs. And I think that's because they were moving faster. Because they were moving faster through the solar system, I think their eccentricity is going to be closer to the circle. And that's exactly what we see in the next row. Their eccentricity of all 7 of them, all of them are less than 0.09. And again, circle has an eccentricity of 0. Their average eccentricity of these 7 is 0.04. That's less than half of what the average eccentricity is for all the other non-binary TNOs, which is 0.11. And then the final row looks at the inclination. How much are they tipped relative to the plane of the ecliptic? All 7 of the widest trans-Neptunian binaries have an inclination less than 4.8 degrees, and their average inclination is 2.6 degrees. That is significantly less than the average of all the other non-binary TNOs of 12.5 degrees. And again, I think that's because the ultra-wide trans-Neptunian binaries move through the solar system faster. That allowed them to travel further away. And it also enabled them to get through the gauntlet of all the giant planets quickly before they were perturbed. And therefore, they're still relatively close to being a circle and near the plane of the ecliptic. So let's conclude with what things have we seen here? Well, the composition of asteroids, comets, and TNOs, I think, supports the hydroplate theory. And I didn't want to get into all of it because I knew Kevin would be getting into it, but asteroids and comets, organic material has been found on those. They've all been found to have water on them, including TNOs like Ultimate Thule that I showed you before. The composition of Pluto supports that as well. They're made up of rock piles. And again, if you haven't seen it, I encourage you to go try to watch Kevin's video of the impact of the DART mission. They have water ice on them, and we talked about the crystalline water ice. Pluto's got an atmosphere, losing 500 tons of its atmosphere every hour. There's crystalline water ice on Charon, which couldn't have been there for more than 40,000 years. The binary asteroids and TNOs, the orbital elements of those, all support the idea that they have not been there that long, and that they migrated through the solar system and came from somewhere inside Neptune's orbit. Now, when I published these technical papers, I didn't say that I believe they came from Earth during the flood. I think if I would have said that, they would have said, we're not going to publish this. So I just left it as they came from inside Neptune's orbit relatively recently. And that was shocking enough. shockingly enough, and it was able to get me through the peer review without divulging things like I'm a young Earth creationist, which it wouldn't have been published. And again, the evidence indicates that they came from inside Neptune's orbit. And I think all of this points to the hydroplate theory. And I know it's shocking to think that something like Ultimate Thule, that's way out there, a billion miles beyond Pluto's orbit, came from the flood. But it doesn't take a big change in velocity to get you from escaping Earth's gravitational field to getting to the point where you are really far away. And especially if you have the forces like I described earlier, the Yarkovsky effect and the radiometer effect and just solar pressure pushing you away. And with a huge swarm of rock and water orbiting around the fountains of the Great Deep as they launched. So I think here's some references, but I will stop sharing my screen and open up to questions.
All right. Well, thank you so much. Thank you. That was excellent. Excellent. Nicely done. Nicely done. How do they see something 30, if Neptune's that far away and we can hardly see, how do they see these asteroids that are so far out there?
Uh, well, Ultima Thule was taken by a picture, but I don't think that's the one you're talking about.
No, I'm just
New
talking
Horizons
in
flew within.
general. Yeah,
Yeah,
in general, they're so far away.
they have telescopes that are looking at certain parts of the sky for long periods of time.
Okay. Wow.
Yeah.
That's amazing. That's amazing. And then that planet X9, and is that different than Planet X? Like Walt predicted.
Planet X is a generic. We're
Okay.
looking for another planet out there. Planet
Okay.
9 is saying, "Hey, we found the ninth one." Ironically, the one of the guys who proposed that, his name is Dr. Brown, and so I had to differentiate. I'm different than that Dr. Brown, and he was instrumental in killing Pluto as a planet. And personally, I think Pluto is not a planet. It's doesn't qualify as a planet. But he kind of got some flack for saying Pluto's not a planet. A lot of people said, "Oh, I like Pluto as a planet," but now he's proposing that there's another planet out there. But there are a lot of people now speculating that maybe that Planet 9 doesn't actually exist.
Could Pluto have formed from the material from the hydroplate? Is
Yes,
that okay?
yes, I think
Is
that's
that
where it came from.
is that what you think? That
Yes, yes.
okay, so
And again, I think most people have trouble accepting that because they think a planet came. Well, no, it's not a planet, and that's why I said it's only 0.22% of the Earth's mass. It's very, very small, and it's not very dense, and it has a lot of things that we would expect if it came from there. It's got water, it's got nitrogen, it's got an atmosphere, and it looks relatively young. So yes, I think Pluto formed, and now it's unlike some of the asteroids that look like big peanuts from two
right,
objects coming together.
right.
Pluto looks more smooth and round because the mass was enough to form those things that came together into a sphere.
Okay. All right. Now we'll dive into the questions.
Okay,
Like it says, I thought the radiometer effect relied on some amount of air in the bulb. If no air atmosphere, all that's left would be radiation pressure.
great question. You're right. The radiometer, the little bulb that I showed, there's gas molecules in there, air, and it bounced off that. But the hydroplate theory would say there's water around this swarm of rocks, and that water would get really hot on one side of the rock. Remember, I said that the difference in the moon's temperature is like 270 degrees on one side and negative 240 on the other side. So the water on one side would bounce off with a lot of momentum, and the water on the other side would freeze. And I think there might have been a little bit of atmosphere around it, but I think it was mostly water that was
Okay.
causing that momentum. And I would add this: water has a lot more mass than gas than the atmosphere, and so the water would impart even more momentum as it's hitting it.
Okay. And the ones that got through the solar system faster, would they be bigger objects, or what doesn't the size really matter?
No, that's a good point. They probably were bigger, and the TNOs are larger than asteroids.
Oh,
And the reason I think they would be larger is because the largest objects would have a larger gravitational force to draw more of the water and other rocks around them, which would allow them to have a bigger solar sail and a larger force from the radiometer effect and the Yarkovsky effect, which would give them more force to move away from the sun.
okay. Thank you. And what is your favorite TNO argument that the solar system is young?
Gosh. I, it depends on who I'm talking to. If I'm talking to an evolutionist, I would just say, I would point to the study I did that said over a couple million years, they're uniformly distributed and they're not today. And people are proposing that there's this, and some people have proposed, well, planet nine won't work, but maybe two planets would work or three planets. And they're trying to propose that for just 6 to 12 TNOs. And we showed, oh, no, it's not 6 to 12, it's 1600. They can't, so there's a problem with 1600 of them. Now, if I'm talking to someone else, I might have a different argument, but because I think they're quite a bit younger. I might point to Charon's crystalline ice and,
Okay,
and
yeah,
Pluto's atmosphere.
reminds me of listening to your father on Real Science Radio talking about this and the moon. Okay, you explained this moon, but there's like 90 or 100 other moons in the
Right,
solar
right,
system.
right.
Like, how are you going
And
to
you know,
explain
if
all
they
them?
if they propose a planet to explain six of these, how many are they going to have to propose to explain 1600 of them? And I think a problem that they have, and I can understand this problem, is they've grown up thinking it's billions of years old. That's a fact.
Right, right.
Now make the evidence fit that false narrative.
Yep,
And I said I feel very blessed that I kind of grew up thinking, oh no, I don't think it's that old.
right,
Because from the time I was little, I was exposed to there's evidence that it's not old.
right,
Yeah.
right. Yeah, that's a tremendous blessing. Does NASA agree that the mass of the TNOs is a small percentage of the mass of the Earth? Would they agree
Yes,
with that?
actually, my father's estimate that 3% of the Earth's mass was lost and became TNOs and asteroids is based on other people's studies of what's the total mass of all the TNOs and asteroids together and comets. And one study showed it was about 2% of the Earth's mass, and one study showed it's about 4%. And so my dad said, well, let's look at maybe could 3% of the Earth's mass have left? And yes, that's based on evolutionist uh, estimates of the total mass.
Okay, thank you. And what arguments? What's your favorite argument for the showing the youth of a solar system, the solar system?
Well, you could pick lots of things on Earth because we're part of the solar
Oh,
system.
sure,
Uh,
sure. We can we can come back to that one too
that
if you want.
there's a lot of arguments to argue that. And
Could it
I
be
think that
Saturn's rings, like Saturn's rings? They're falling apart. They can't be there that long, or comets, or
yeah, I would actually point to things outside the solar system that are more so that we see galaxies that are spiraling around.
sure.
And when evolutionists look at those, again, they look at them and say, hey, those galaxies are 4 billion years old, but they're spiraling so fast, they should fly apart in 4 billion years. So you know what they do to come up to solve that problem?
Dark matter.
Dark matter. They come up with a whole new
Oh yeah.
force that doesn't exist. And
Yeah.
and we don't have any evidence for it anywhere in our solar
No.
system. But they said dark matter must be holding it together. Uh, they're it's a fictitious thing to try to explain something that they can't otherwise explain because they're stuck on billions of years.
Oh yeah. Then you got dark energy and dark matter, and
Yes,
that is
yes,
like 96% of the solar system or something like that,
yes.
or 94. Oh, let's see here. That was a good question. What percentage of the Earth do you think was ejected into the orbit? And
Well,
and how many Plutos that might be?
oh, how many Plutos? Oh gosh, I'm not sure. About 3% of the Earth's mass. I'm not sure of the Neptune is a whole lot bigger than how many Plutos? Well, Pluto's 0.22%, and I'm saying about 3% became that. So I'll do the math real quickly.
And then look at this guy on the spot. Johnny on
That's
the spot.
about 13 and a half Plutos.
Wow, that's excellent, excellent. How about the other moons going around other planets? Could they come up from like Jupiter's moons or Saturn's moons? Could those come from the fountains of the Great Deep also?
Yes, I think they did. Especially there's many small moons. For example, Mars has two moons. They have very, very low density, and a number of these moons they've discovered that they have water on them.
Right. Some of it's shooting out like a geyser. How would that
Right.
work? Why would that, how would that work, do you think?
Well, if they had water that froze on them, and
Mhm.
then it's exposed to the sun, it would be like a comet, and gases would come out.
Would tidal pumping, would that cause heat for that to come out
Yes,
also?
especially if they get close to a big planet,
Okay.
it could warm
Okay.
it
Because
up.
I think Enceladus or whatever, one of those
Yes,
planets.
Enceladus. Yes,
Yeah, that's the one. Is that Jupiter or Platurn?
I think it's Jupiter. but
Okay.
don't quote me on that.
Okay. When the ruptured water went to space with rock, what state would that be? Ice, steam, supercritical, liquid?
Well, I think it was supercritical when it was underground,
Yep.
and then as it was launched, it very quickly froze.
Oh,
It got to space. When it got to
right.
space, it would freeze. And as others have talked about, a lot of that would have just come down as huge ice dumps burying the frozen mammoths on Earth. But some of it, I think, would have started orbiting as ice crystals around these swarms of rocks.
Right.
Now, if it hit the rock and the rock was warm, then that frozen water would evaporate very quickly and impart some momentum to push it away.
Okay. Has there been a modeling done to arrive at a point from where and when the TNOs originated?
No, and the question is why, the problem is this force that I'm saying, and I shouldn't say I'm saying it. My father proposed this, and I've mentioned it in the papers I published. That force doesn't exist today because the water is now frozen. So the Yarkovsky effect is not no longer pushing these TNOs further away. So how do you model going back in time a force that doesn't exist today? And how it's very difficult to come up with the parameters for what that force would have been like, 1,000 years ago.
Sure, sure.
I have tried to propagate comets back in time to see if because there's some periodic comets, Hubble and Swift Hubble are two of them, and see wouldn't it be great to show that they came very close to each other about this year and plot and close to the Earth, and the non-gravitational forces are very difficult to model, and especially if you go back really far in time.
Okay, and then there's that asteroid that's coming through that they think came from outside. I think you might have answered this earlier. Somebody
Yeah,
did.
yeah,
That's
I talked about this earlier. It's got a Hawaiian name. I don't.
yeah, yeah. Go ahead.
And some people say, hey, this poses a problem for the hydroplate theory. I don't think it does. My father predicted, and I'll explain why he made this prediction, that you'd never see a comet or an asteroid coming into the solar system on a hyperbolic orbit. That they would be on elliptical orbits because they started from the Earth and they're just coming back again now. But he said but this comet, I'm sorry, this asteroid is on a hyperbolic orbit, but it wasn't observed on a hyperbolic orbit coming into the solar system. It's already inside the solar system. So you'd have to track it back and find out, did it ever come close to another object? And we don't
Yeah.
know because, frankly, I mean, I was looking at 1,600 TNOs, but there are a lot of other TNOs that haven't been found yet. And some
Wow.
of the estimates of that 2 to 4% is accounting for TNOs that haven't been observed yet, just based on the cycle of where we've seen them. So that 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 asteroid is on a hyperbolic orbit and it's going to leave the solar system and never come back, but it wasn't coming into the solar system on a hyperbolic orbit. And we don't know what it was coming in on because we didn't see it before it was well inside Neptune's orbit by the time it was seen. I think it was around Earth's orbit by the time it was spotted.
Okay. Okay. Thank you. Yeah, I think I saw that on rsr.org on their
Yeah.
lists of the hydroplate, and that was one of the major criticisms of the hydroplate. I'm thankful that you answered it. Okay, and if the Earth was the point of departure, I would have thought their orbit would have returned to a point near the orbit of the Earth. Are the three effects you mentioned the reason that they for that?
Yes. It would if there was no other force pushing them. But I think those other forces, the Yarkovsky effect, the radiometer effect, and solar pressure, would have pushed them away to a new orbit. I made that argument the similar argument in response to evolutionists who say that TNOs formed inside Neptune's orbit and then flung them out to the orbits that they're in today. They don't propose any sort of non-gravitational force like the Yarkovsky effect. They just said they were flung out and they would come back to the point that they were launched from. With Earth, if they were launched from Earth, though, I'm proposing there's another force that kept them moving away from the sun that evolutionists had never thought about with their theory,
Okay, now
because they had water around them and a big solar sail, a big swarm that would have propelled them away, and their orbit would have changed drastically, which makes it really hard to propagate them back in time.
sure. Okay, thank you. Okay, do you believe the source of the past water on Mars, as evidenced by erosion, is a result of the hydroplate? And if so, how could the relatively small gravitational field of Mars be likely to capture the water given in the vast area of space that the water could travel?
Okay. Yes, I do believe it came from the hydroplate theory. In fact, my father predicted that the erosion channels, they'd find salt in those channels. And a few years after he made that prediction, the Mars rover discovered there's salt in those channels. And he said the reason he said salt is because it came from the oceans. A lot of the debris would have just stayed in the plane of the ecliptic. And if it didn't have a large swarm around them, it might not have been blown out of the solar system that long. And as Mars goes around, Mars would come in contact with some of that, and then that water would end up on Mars. Now, what's interesting is, do you see that with Venus? No, you don't, because Venus is inside Earth's orbit, and these things were being pushed away from Earth, the sun. Does that make sense?
Interesting. So would Venus have gotten hit with anything from the HPT from
It could
hydrogen?
have, but it would have been a direct hit. Not so. Let's just say that. Let's say the Earth. There was this huge explosion on Earth, and all the debris
Yep.
was around one astronomical unit from the sun.
Yep.
And then the solar wind would start pushing it further
Oh,
out.
I see. I see.
Okay.
I see.
Now, if it had enough velocity to escape Earth and go straight towards Venus, yes, it would hit Venus. But I
Okay.
think as this debris would slowly move from one astronomical unit away from the sun,
Right.
eventually Mars would fly by and hit a bunch of those.
And they've got that canyon. It's bigger than Grand Canyon on Mars. They got a huge
Yeah,
canyon. They try to say it's a split. I mean, what could there have been enough water on from the hydroplate to do that, or could that be a crack in the Mars?
I'm not sure. It could have been either one, but there are erosion channels there that most people, before we ever, just from looking at telescopes, said, "Hey, this looks like a water erosion channel." And those were the ones my father said, "I bet you'll find salt there." I don't think that's the large canyon you're speaking about,
Right.
but
Right.
maybe it may be a combination of both explanations.
Okay. What is the Earth's eccentric E value compared to TNOs?
Oh,
I don't know what that means.
I could look it up real quickly.
Uh,
Uh, the Earth is almost a perfect circular orbit. It's it's very close to a circle.
and the moon's is too, right?
The moon's is a little bit more eccentric, I believe, but
Okay. Okay. All right. Concerning Mars, 80% of the impact craters are found within one hemisphere. That could lead to the possibility that they were all hit within a few hours of each other. What are your thoughts on that? Boy, that's news to me.
that's news to me too. I would think that it might have been a longer period of time. I can understand the moon, like when Doug's talked, being hit by one on one side because it's so
Right.
close.
Right.
But I would think Mars, it would have been spread out a little bit more, just because it wouldn't have happened within hours. I,
Would it hit the same side of Mars? If this is the case, it got mainly hit by on one side, if that's
well,
accurate.
I think as Mars is going around, they'd hit mostly on the part of Mars that's closest to in the direction it's moving. But Mars is also rotating on its axis, so no, I don't think it would.
Okay, and
Now,
that one's rotating rather slowly, right? Like Jupiter's rotating like at top. Is Mars the one that has like a year rotation or something?
I know it's rotating a lot slower than the Earth, but I don't know how
Right.
slow.
Okay, is the probable inclusion of water from Earth a reason why Mars is red?
Yes,
Really?
a lot of people think Mars is red because of rust.
Oh, really? And
Now, now there that I'm not saying that's the case, but that's one explanation. But it's just the rocks there that are red. Now, I'm curious, and I would ask this question. So, do you think it was red before the flood?
sure,
I
sure.
maybe it was, maybe it
Yeah.
wasn't.
Yeah. Okay. All right. And it looks like, oh, somebody asked me a question. This is off topic. This is more on the Earth during the flood. And they said, with all that stuff going up and burying the fossils and all that, or burying the mammoths and stuff, would that destroy the ark? If it's so turbulent here, how did the ark survive that turbulence?
Uh, well, thank God was looking after it. But it is interesting. The Navy did a study once, the U.S. Navy. What
Yeah.
are the best dimensions for a ship? If I don't want to make it go
Oh, yeah.
fast, I just want to keep it from sinking. And the dimensions are the dimensions of the Ark.
Oh, yeah. Oh, yeah.
Uh, but yes, I'm sure it was a perilous time for Noah and his family.
Oh, yeah.
I'm sure they were very scared.
Yeah, I heard of that guy. He just changed one certain things and it would just mess that up. Yeah, it
Right.
is the perfect.
I'm sure they felt like they dodged a lot of bullets, but I think ultimately it was God was watching out for them.
Right, right. Oh, and yeah, let's say your experience going through the Air Force. Was it hard to be a creationist going through college or anywhere, or not
Uh,
so much?
Sort of. I mean, now that I'm a professor, I think there are some people that look at my record of publications when I come up for academic promotion. I have a paper in my dad's online book called "Did the Pre-Flood Earth Have a 30-Day Lunar Calendar?" And people told me that should not be in there. You should get rid of that. That doesn't belong in a professor's CV.
Oh,
Uh,
wow.
but I just kind of think I don't care what they think. But for a while, I was getting rejected by technical journals, and I told my dad, I said, Dad, if you Google my name, the number one hit is your book, and
Oh, sure.
maybe I'm being blacklisted. Can you change it to Dr. R. Brown instead of my full name? And so I was anonymous for a while. In the ninth edition, I will not be, uh,
Okay.
just because I don't care about if I get blacklisted and don't publish technical papers anymore.
Well, it'll show how much they allow a freedom of thought. If they come after you,
Yes.
it's not that they want to educate people. It's what they want to indoctrinate
Well, I
people.
was disappointed and asked the professor in charge of that academic promotion. I said, "Have you read the paper, or did you just look at the title? Because if you
Yeah.
read it, it's very technical, and I don't think anyone in my department, except maybe one other person, would understand it."
Oh, we got a question for Ryan. What's your preferred solution to distant starlight, the
Oh,
distant starlight issue?
uh, my preferred solution is and let me explain the distant starlight problem. It's if you see stars that are billions of light years away, doesn't mean they're billions of years old, and there are a lot of explanations for that. My preferred explanation is in the Bible. Every time it's used about 7 different times, it talks about God spread out the heavens, and when it does, the verb there is like to spread a tent on the ground. And I think God created everything, and then He just spread them out like this. And as He spread it out, that explains the redshift that we see. The universe is moving away at an accelerating rate. You talked earlier about dark energy. Evolutionists can't explain. Everything's moving away, but you think it moves slower and slower as gravity pulls it back in. No, we see it moving faster and faster. So I think God said, boom, and I'm going to spread it out. And I think the heavens declare His handiwork, and the glory of God is on display in the heavens. And God said, I'm a big God, and we're going to have a big universe. And He threw them out.
Amen.
That's
Amen.
my explanation.
Amen.